Alright, recording in progress. Okay, so saya nak tukar ni. This is in polar coordinate. This is in rectangular region. And then this is in polar coordinate. Okay, so how to approach this? Okay, macam mana saya nak buat change of variables? So yang ni nama dia change of variables from x to r and theta. Okay, let's see this one. Let's use the same application. Okay, kalau saya ada, let's say I have this segment ataupun sector. Okay, yang kat sini. Right. So kalau awak bayangkan, if you imagine that this in three-dimensional axis. Okay, so kalau awak tengok kat sini in three-dimensional axis, saya punya apa dia? Saya punya sektor ni dia duduk di sini. So this one is this region R, and then ada some kind of surface dekat atas ni. So dia daripada sini. So dia akan membentuk a solid. Okay, now let's look at this one. Ya. Saya dengar macam ada suara macam nak tanya soalan ke apa ke. Okay, setakat ni ada soalan setakat ni. Any question so far? Okay, so tak ada masalah Okay, let's say this one. We use the same application, which is we need to find the DA, area DA kat sini. So kalau saya besarkan kat sini, so this is DA. So it looks something like a polar coordinate, macam sedikit, bulat sedikit. So if I zoom in like this, so yang the length area untuk area for a sector is what? Area untuk sector. Daripada apa ni? Add map dulu. Area untuk sektor. Tak ingat dah. Fatin tak ingat Fatin? Area untuk sektor. Okey, awak ada ke tak ada semua orang ni?
Ada.
Ada. Okey. Okey, so apa dia area untuk sektor? Yang lain pun tak perlu, kalau dia rasa dia tahu boleh je tulis dekat chat ni. Area untuk sektor apa dia?
R square pi over 2.
Pi. Jangan guna pi. Okey, sebab dia adalah sektor. Pi tu dia mungkin merujuk kepada half a circle ataupun apa dia? Half a circle ataupun circle. So dia adalah
Theta over 2.
setengah half r squared theta. So theta can be anything, it not necessarily be pi. Okay, theta can be 1.2 something. So theta tu apa? Theta is this. This is the theta that you want to find. So kalau let's say kalau saya nak find this area, the whole area kat sini. So this is the theta. Okay, so but in this case kita tak nak yang ni. We want only small theta. So this is small theta. This one, d theta. Small theta. And then what's this? This is dr, small radius. Okay, so in that case, kita nak cari dA. Okay, so dA is what? So kalau mungkin apa ni? Kalau saya tak nak yang kecil lah. Okay, let's start with big one first. Okay, let's see, this one is R1. So yang ni adalah R2. Kita ambil yang besar dulu. So R1 is, let's say this is A. The length right here is A. And then R2 is B. Okay. And then kalau saya buat ini adalah theta 1. And then yang ni adalah theta 2. Okay. So kalau saya masukkan formula dekat sini, A sama dengan 1/2 R kuasa 2, R squared is this length, right? So maksudnya B minus A squared times theta 1 minus theta 2. Okay. So kalau saya expand yang this, 1/2 B minus A squared is just A plus B. So, saya tak nak buat dia dalam kes ni. Saya nak ikut dengan ni. B minus A, B plus A, B minus A times theta 1 minus theta 2. Okay, are you guys with me so far?
Yes.
Okay, so and then kalau awak recognize yang ni, B plus A, so this one, this guy, this expression, B plus A divided by 2, so this is as if, kalau tengok ini balik, B is what? B is R1, A is R2, so this is like taking the average R1 plus R2 divided by 2. So yang bahagian yang ni, this coefficient, this constant coefficient. Okay, let's say kalau saya kata, so let's say this one is equals to R star. Okay, so saya boleh plug back dekat sini. R star is just B minus A times theta 1 minus theta 2. So this is the area untuk sektor yang kat sini, this sector. Okay, so kalau saya nak buat dalam bentuk yang kecil, so saya nak apply, I want to apply this into this small rectangle yang kat sini. So this small rectangle. So macam DA, so saya apply balik for a very small, let's say IJ, something like that. So saya boleh apply DA equals to R star. So B minus A is what? B minus A is just dr times d theta. R star times dr d theta. Okay, so kita dah dapat yang bahagian yang kat sini. So we already get this one, this part. So dA in this case adalah R dr d theta. So saya nak tuliskan balik dia sebagai double integration over under region R, over region R, F R theta, R dr d theta. Okay, so kalau kita, if you remember from last time, we have integral over R fxy dx dy, and then we also, this is equal, so this is from Fubini's theorem, R fxy dy dx. Sebab apa? Sebab dari mana-mana arah pun kalau awak ambil, disebabkan sebab this is the volume will be the same. Sebab apa? Sebab dia nilai volume saja, dia tidak menunjukkan nilai apa-apa, any direction or something like that. So sepatutnya volume dia sama. Awak ambil your iterated integral dx dulu ke dy dulu ke, tak kisah. Okay, tapi in this case untuk polar coordinate tak boleh. Okay, sebab apa yang ni? In polar coordinate dA sama dengan R star dr d theta, saya tak boleh buat R d theta dr. Kita tak boleh. Kan? Sebab apa? Sebab kalau awak tengok dekat dia punya original figure kat sini, let's say this original figure, R dia, kalau awak tengok, kalau awak apply yang kita buat tadi, so the angle dia akan always constant from where to where. So kalau awak tengok kat sini, let's say let's redraw this one. Kalau ada cake, you have a piece of cake. So angle dia akan start daripada, let's say this is theta 1 and then you end at theta 2. So you can pick any number, theta dia akan masuk sini dan dia akan keluar ke theta 2. Okay, tetapi let's say you have another cake, a piece of cake. Macam ice cream sikit. Okay, let's see this one. What's the difference between, apa beza di antara R1 dengan R2? Okay, the difference is the radius. Theta always start from constant value. Let's say this one is equals to pi over 3, and then this one is not pi over 3. Let's say this one is pi over 4, and then this one is pi over 3. Okay, so theta dia tak ada variable. Dia bukan, if you look at this one, what does it mean by variation? Dia bukan macam ni. So nampak tak? Dia punya theta ni dia tak. Kalau kat sini theta will be varies. Dia akan this is a function, something like a function. Dia always straight line. So dia always a constant. Kalau dalam kes ni barulah theta varies. So yang ni kita tak pakai. So we don't use this kind of stuff. So that's why kalau kita nak tukar untuk dA, if you want to integrate the region R F R D, theta is always R dr d theta. Okay, ada soalan setakat ni? Okay, sama juga kalau kita buat dengan Riemann sum. Kalau saya buat dengan Riemann sum, benda yang sama apply. So maksudnya kalau saya buat dalam Riemann sum, dia akan jadi apa dia? So this is the Riemann sum for Cartesian coordinate I equals to 1 to m, j equals to 1 to n, fx ij star y of ij star, and then daij. So if you still remember apa maksud I, apa maksud j ni. So that one is not supposed to be there. Nampak madam. Okay. Balik lah. Sorry. Okay. Let's see. Okay, and then aij. So yang ni merujuk kepada. So this one is for, if you remember, this is I from 1 until m, and then j from 1 until n, and then this is for a11, a12, dan seterusnya. Sorry, a21. Then this is a21, a22, and so on. Okay, so itu masuk dia punya index ij. Okay, so this is equals to what? Benda yang sama, same thing. I doesn't change to m. J also doesn't change because why? Because this is just the index, the indices. Dia punya position dia di mana. And then untuk for x is what? If you remember, x is what? X equals to r cosine theta. Y equals to r sine theta. Okay, so if you plug in this back, you will have r x star, r star of I, and then cosine theta of j, and then r of I, sine theta of j, r star, delta r, delta theta. So this is the equivalent for polar coordinate. Okay, ada soalan setakat ni? So if you want to take the limit goes to infinity, dia akan jadi exactly exact integral. Okay, so the definition for this one is, ini penting. Okay, if you want to change the polar coordinate, so let's say if f is continuous, continuous on R, and R is given by R theta, which is R goes from A to B, and this is always zero, bigger than zero. Dia sebab apa? Sebab R always bigger than zero. Kenapa R bigger than zero?
Sebab R tu radius.
Apa dia? Saya tak dengar R tu apa?
R tu radius kan?
Saya tak dengar. R tu dia radius. Radius, so logik tak radius tu dia Dia length, dia macam pembaris lah kan. Pembaris tu mana ada pembaris nilai dia lebih kecil pada kosong. So R is the radius. Okay, and then theta goes from say alpha and then beta. And usually beta minus alpha is between 0 and 2 pi. So that makes sense because the maximum angle for circle is 2 pi, minimum angle is 0. So that just makes just give a notation that B beta minus alpha is between 0 and 2 pi. So kalau contohnya kalau awak try dapat value yang lebih besar daripada ni, so maksudnya something is wrong lah. Okay, sebab apa? Sebab dia bukan yang macam kita rotate Q1, Q2, Q3, Q4 tu. Sekali saja. Okay, so then the definition is just integrate for rectangular R fxy dA is equals to, so f x apa dia? X adalah cosine theta R sin theta untuk y R dr d theta. Okay, so R is what? R is the inner integral, so R goes from A to B, and then the outer integral is from alpha to beta. Okay, and don't forget, always selalunya student buat mistake dekat sini. Sebab apa? Lupa nak letak, you forget to put the R dr d theta. Okay, so let's look at an example. Okay, so kalau dia kata you have integral of R for 3x plus 4y squared dA. Okay, dan apa ni? Don't forget this parenthesis, because sometimes people make mistake when you don't have parenthesis, you forgot to multiply. And then R is region in the upper half plane bounded by circle x squared plus y squared equals to 1. So this is easy. Radius is just 1. And x squared plus y squared equals to 4. So this is also easy. So R2 is 4. Okay, so if you put this into sketch the region, okay, key point dia kata apa dia? Key point dia kata this is on the upper half plane. Okay, upper half plane tu maksudnya apa? Kalau saya tengok kat sini, XY plane, upper half plane of XY. Dia macam tersembunyi sikit kat situ. Okay, so maksudnya kalau kita tengok dekat sini, XY, this is Y, and then this is X. Upper half plane dia bahagian yang Y is bigger than 0, this line. So this is this line. Belah atas. Okay, so kalau kita lukis dia punya Mana ni? Undo. Okay, so kalau saya ni balik, apa halfling? X squared plus y squared equals to 1. So this is this circle, not to scale. And then x squared plus y squared equals to 4, this circle. Okay, so the region is bounded by this part. So this is in terms of visual. Okay, so yang ni dalam bentuk visual. So kalau kita nak tulis the region, so if you want to write the region, so R is just in terms of x, y. So y is bigger or equals than 0. Sebab apa? So this one. And then x squared plus y squared is in between 1 and 4. Okay, so this is 1, this is 4. So in between this region. Okay, so kalau saya translate dekat polar coordinate. So yang ni, kalau awak tak nak buat yang ni pun tak ada masalah. So this is no problem. This is optional. Okay, kalau saya translate dalam polar coordinate, R and theta. So this will be R in between 1 and apa dia? Saya silap kat sini dah. So this is my mistake. Okay, so this should be 2. Sebab apa? Sebab this is equals to R squared. So therefore R equals to 2. Okay, so this between 1 and 2. And then the theta between what? So theta is from this angle and then sweep in this angle. So daripada kosong sampai pi. So this is from 0 to pi. Okay, so and then kita kena tukar 3x plus 4y squared. So 3x plus 4y squared. So we need to change to fr cosine theta and then r sine theta. Okay, so macam mana? So just plug in the formula. So this one will be, so let's say this is g of r and theta. So g of r and theta will be 3r sine, sine pula dah. 3r of cosine theta times 4, not times, this is plus 4r squared sine squared theta. Okay, so awak just replace the formula for x into r and theta, just that. Okay, so the whole thing will be 3r cosine theta plus 4r squared sine squared theta r dr d theta. Okay, so r goes from what? R goes from this one. R is from 1 to 2. And then theta goes from 0 to 2 pi, or just pi. Okay, so I believe that you can solve this. Okay, ada soalan setakat ni? Okay, tak ada soalan. Let's look at another example. Okay, find the volume of solid bounded by z equals to 0 and z equals to 1 minus x squared minus y squared. Okay. So maksudnya kat sini, apa kita punya ni kat sini? So kita tak diberi region R, tapi diberi region of intersection. So dia akan, kita kena buat kerja lebih sikit lah. Okay, dalam kes ni, intersection meaning that there is some point yang dia akan intersect, benda yang sama. So kalau awak pergi dekat, let's use this plane, let's share. Kalau saya pergi dekat Math 3D ni, masing-masing boleh cuba tengok dia punya region. Let's say Math 3D. Sekejap Okay, resume balik. Integral in polar coordinate for general region. Okay, apa maksud general region yang saya maksudkan macam, okay, tak apa. Okay, so kepada yang itulah, so tapi tak apa kan, ada recording tu, saya harap awak membantulah juga untuk ni. Okay, saya tak nak guna method ni sebab saya takut nanti tak ada ni. Okay, let's change my presentation to this one. Okay, let's see this one. Okay, in polar coordinate, still in polar coordinate, double integral for general region. Okay, apa maksudnya general region? Okay, kalau awak tengok yang saya tulis tadi, saya lukis tadi. So if you have a sector, this sector, same thing on XY plane, and then I have some kind of something like this. Okay. So kalau saya ambil, so let's say this one is for, let's say this region, this line. Okay. Yang ni adalah, let's say this is R2, and then this line is for R1. Okay. So kalau yang tadi, compare kepada yang tadi, so saya buat comparison. This is R1, R2. Okay. Kalau saya ambil point dekat sini, let's say this is R2 of 1. So this one is the same. Kalau saya ambil mana-mana point pun dekat sini, any point. So if I go along this line, R2 akan jadi sama. So this is the same. Kalau saya goes ada gema. Ada orang open dia punya ni kot. Open dia punya mic. Okay. Okay. So kalau saya dah tak ada gema. Okay. If I run through on R1, R1 is also a constant. So yang ni tak ada masalah. So this is at this any point on this R1 dia akan jadi sama. Tak ada masalah. Okay, let's see this one, general region. So kalau saya pilih point di sini, if I choose the point right here versus the point right there, it's not the same. And then if I choose this point right here, it's not the same as, let's say this is A, B, and then C. So the point for A, B, and C is no longer the same. So therefore, dalam case ni, if I say R2 is a function of H2 of theta, and then R1 is a function of H in terms of theta. Okay, so it will be the same thing. Benda yang sama juga. So theta, the same thing. Theta goes from alpha to beta. So in this case, this region D, let's use D, this is D. So D is a region of R and theta between theta alpha and then beta, and then R goes from H1 of theta and then H2 of theta. So this is the region. Okay, so how do you want to express the double integral? Sama. Apa yang beza dia adalah dia punya limits. So the volume under the graph above the axis, above the region, is just f in R, fxy dA. So this is the same thing as that theta goes from alpha to beta. R1 goes from H1 in terms of theta and H2 in terms of theta, and then f of x become R cosine theta, R sine theta, R dr d theta. Okay, special case. Let's say fxy equals to 1. So the height is 1, meaning constant height. Can be anything, but in that case, in this case, try 1. Sebab dia apa? Sebab dia, this is easy number. And then h of 1 equals to 0. Apa maksud h of 1 equals to 0? Meaning that this is start on original point. Maksudnya start dekat sini. Yang dekat apa dia? So if you look at this one, this is h of 1 of theta equals to 0. Okay. So kalau kita buat kat sini, therefore H2 kita boleh kata, therefore we can say that H2 is just H of theta because we no longer have H1. Okay, and then kita kata area bounded by theta is just equals beta equals to theta. So and then dia punya requirement satu lagi, requirement dia theta equals to alpha and also theta equals to beta. So dia tak ada masalah sebab ingat tak tadi requirement dia apa? Beta minus alpha is between 0 and 2 pi. So we take this limit. Okay. All right. So the double integration will be over region D is just fx y dA sama dengan 1 dA. Okay. So if you translate into polar coordinate, dia akan jadi dA apa? R dr d theta. And then R goes from 0 to h theta. Theta goes from alpha to beta. Okay. And then this will be 1/2 of alpha to beta. It's just h squared of beta. Sebab apa? Because this one is what? This one is just the inner part. So if you evaluate the inner part, kalau saya buat kat sini, from 0 to h theta r dr. So this is just r squared over 2 evaluated from 0 to h theta. Okay, so dia akan jadi h squared of theta divided by 2. So kalau saya take out the constant, dia akan jadi macam ni. Okay, sebab tu saya. So kalau saya theta, if alpha equals to theta and beta equals to theta, obviously dia akan jadi kosong. Okay, so in this case, it has no volume. But if it's not equal, then dia ada nilai dia. Okay, H2 can be anything. Okay, so kalau dia, if it's a circle, so it depends. Kalau H ni adalah a sphere, sebab tu akan dapat H of theta. So you have maybe a sphere or maybe a cylinder. Okay, so the formula for third pi r cube ni datang daripada sini. Datang daripada formula yang ni untuk volume. Silinder pun sama juga, if it is cylinder, dia akan keluar formula untuk silinder. So this is how they get the formula. Okay, let's do some example. Okay, find the volume, sama juga, find the volume of solid under z equals to x squared plus y squared. Okay, yang pertama, under this one. And then above xy plane. So dia punya key dia above xy plane. And cylinder x squared plus y squared equals to 2x. Okay, so Kalau awak nak apa ni, if you want to look at the graph pun boleh. The apa dia? Look at the sketch. You can try the sketch to sketch this one. Okay. So the thing is ada tiga. So this one is bounded by 3 surfaces. Okay. So yang penting kalau tengok kat sini, you have 3 parts. Z equals to this above XY plane, and then cylinder this one. Okay. So yang ni dia macam parabolic sikit. Okay, sekarang ni apa yang mungkin membawa masalah kepada kita adalah this part. Okay. So kalau saya tengok dekat XY plane, above XY plane, so kita tak perlu risau yang apa ni equals to anything. Okay, let's see this one. If you have x squared plus y squared equals to 2x, and then kalau saya pergikan di sebelah kanan, x squared minus 2x plus y squared equals to 0. Ini sebab dia tengok dekat apa ni, dekat xy, above xy plane ni. So z equals to 0. Okay. So kalau saya buat x minus 1 square, okay, saya nak jadikan dia completing the square, plus y squared equals to 0. So this is x minus 1 squared plus y squared equals to 1. Okay, so kalau saya buat macam ni, apa maksudnya? Maksudnya dia punya circle tu dia off daripada dia punya original O tu, titik O. So dia ke kanan sikit. So kalau saya lukis dia punya circle, salah. Agak-agak lah. Lebih kurang kat situ lah. Okay, so kalau saya buat kat sini, so dia punya point dia punya original sekarang di sini. Radius doesn't change. This is the radius. So radius doesn't change. Radius equals to 1. Tapi dia punya center dia dekat x equals to 1. Okay, so this is x equals to 1. This is 1. And then this is 2. Sebab apa? Sebab radius dia 1. Okay, so apa dia punya problem kat sini? Sebab kita nak cari dia punya boundaries. Boundaries untuk R. Okay, so R dalam kes ni, apa dia punya function? Apa function untuk ni? Macam mana kita nak cari? Kita boleh guna function yang ni. You can use this one. Okay, so kalau kita apply tadi, x squared plus y squared, x squared plus y squared, this is equals to r squared. Okay, and then if we use 2x, so this is becomes 2r cosine theta. Okay, so kalau saya gabungkan dia punya ni, so r squared equals to 2r cosine theta. So therefore r becomes 2 cosine theta. Okay, so this is the function. If you remember, yang ni function apa dia? Function untuk h of theta. So kalau ingat lagi apa dia? Dia punya h of theta, mana dia punya region dia? So in this case, kalau awak tengok balik region dia yang di sini. H1 is 0. Sebab apa 0 H1? Because if you see that this one is H1 of theta, and then this one is, this line is H2 of theta. Okay, so how about the angle? How about the angle? Macam mana nak cari dia punya angle? Theta from where to where? Is it from 0 to 2 pi? So let's highlight this one. So now R is between H1 of theta and then H2 of theta. Okay, now we knew that H1 is 0 and then H2 is 2 cosine theta. So kita dah beres bahagian boundary untuk R. Now we need to find the bound for the limit for theta. Okay, so macam mana nak cari? So if you zoom in, kalau saya zoom in dekat sini, say this area, let's use zoom in this area, sebab yang tu akan menentukan kita punya theta. Okay, so kalau saya zoom in, dia punya ni, dia macam seolah-olah as if like a straight line. Macam tu. Nampak ke apa yang saya ni cuba ni? So dia macam line di sini. So maksudnya dia daripada bulatan ni sebelah sini kan, bulatan ni sebelah sini. So this from this point, theta daripada this point until this point. What's the value for this point? What's the angle for the first one?
Pi.
Pi/2.
Yes, pi over 2. And this one is minus pi over 2. Apa ni? Kalau awak nak buat dia punya apa? Dia punya how many this? Dia lebih kurang sama je. Okay, so this is from pi over 2 to minus pi over 2. Okay, so theta is now in between minus pi over 2 and then pi over 2. So in this case. Okay, katakan, let's say saya cuma ambil, the question is only asking for this one. Only half of that. Okay, only half of that. Now, theta saya dari mana ke mana? So kalau saya awak zoom in kat situ, make it bigger. So dia yang ni adalah, this is the line. See, this is the line right here and then the line right there. So the line right here and then line kat sini. So this is the region that we are interested in. Okay, nampak tak? So dia akan jadi start from this theta and then end at this theta. Okay, so dia akan start daripada 0 to pi over 2. Alright, boleh? Boleh ke?
Boleh.
Boleh. Okay, so the key point, tak apa, kita selesaikan dulu, nanti saya cerita pasal key point dia. Okay, so the whole thing will be V just equals to, in the region D, okay, and then the function fxy itu apa dia? Tak apa, kita tulis dulu fxy dA equals to integration from what to what, fxy dA, mana function yang kita nak guna? Okay, kalau dia kata solid, volume of solid under this function. So this is the function of fxy. So z equals to something. Okay, so this is just x squared plus y squared dA. Okay, x squared plus y squared. What is this? This is just r squared. So in that case, integral from, for r squared times dA is r dr d theta. R from h1 is 0, h2 is 2 cosine theta, and then theta goes from minus pi half to positive pi half. Okay, mungkin satu lagi, mungkin awak kata okay, mungkin yang ni 3/4 pi, right? So this is like awak pun boleh guna yang apa ni, 3/4 minus pi half ni pun dia kalau awak nak guna sama benda yang lain pun tak ada masalah, asalkan dia punya ni, sebab dia adalah macam rotation tu kan, dia rotation, dia tak ada masalah kalau awak nak guna value yang lain, sebab nanti pun dia akan jadi sama. Okay. Okay, so this is just the setup. Awak boleh, you can solve this on your own. Okay, ada soalan setakat ni? Tak ada. Okay, let's look at some examples yang ada dalam exercise kat sini. Okay, let's look at if you notice that apa yang saya buat, saya tak nak selesaikan, saya cuma nak bagi setup of the problem. Okay, let's look at the highlight for key point. Number 1 is region in x, y, 2, r, and theta. Maksudnya apa? Maksudnya x goes from, let's say x goes from A to B, and then y goes from C to D. Similarly, if you want to use theta goes from alpha to beta, and then r goes from, let's say, for general region, h1 of theta, and then h2 of theta. Okay, the first thing awak kena buat dulu, find the bound. So find your boundaries. Sebab tu kena ada sempadan. Kalau tak ada sempadan, kita tak boleh buat. Ada had ni. Okay, sebab tu kalau apa ni, ada batasan dia. Setiap perkara ada batasan dia. Tak ada perkara yang tak ada batasan. Kalau tak ada batasan, awak tak boleh nak solve the problem. Okay, dan yang kedua, the second part is the function fxy to g r theta. Okay, yang ni tak ada masalah sebab the whole thing 1 and 2 key formula is definition of how to change from x and then r using r and theta. Okay, so use this formula. Always remember that x equals to r cosine theta, y equals to r sine of theta. And then x squared plus y squared equals to r squared. So this basic three formula is the only thing that play in this double integral over polar region. Dia tak lari, cuma ada twist sedikit saja. Okay, let's see some example yang at the end of the lecture notes. I just want to use the setup of the how to set up. Let's say example. Let's say number 5. Soalan dia apa? Soalan dia evaluate the given integral by changing to polar coordinate. Okay, the original integral cosine of x squared plus y squared dA. And then r lies above x axis, macam above x axis ke above xy plane, dia tak jelas ni. Within the circle x squared plus y squared equals to 9. Okay, saya rasa dia ada apa ni, dia ada dia ada macam typo sikit. Above x axis ni saya rasa dia above x y plane. Sebab dia kalau dia merujukkan kepada tiga segi above ni, dia di atas kan. So it doesn't make sense kalau dia tak sebut dengan y plane. Sorry, y juga. So dia macam seolah-olah this is as if it's just, kalau dikata above x axis, so dia hanya ambil surface ini sahaja. Sorry. Yeah, above this one. So yang ni macam tak ada apa kaitan dengan yang kat sini. So soalan tu perlu dijelaskan sikit. Okay, tak apa. Tak apa, kita ni lah, dia mungkin typo, tak ada masalah. Okay, so the question is, lies above xy plane within circle this one. So maksudnya dia adalah on y positive value yang ke atas ni. So circle x squared plus y squared equals to 9. Okay, first thing first, find the boundaries. Okay, so kalau saya tengok dekat sini, this is just x squared plus y squared equals to r squared equals to 9. So therefore r is 3. So in this case, within the circle, maksudnya dia di dalam circle tu, so the boundaries is just from 0 to 3. Within the circle. This is circle. Within the circle, dia di dalam tu. Just from 0 to 3. And then how about theta? So this is a circle. So theta maksudnya just from 0 to 2 pi. So theta is from 0 to 2 pi. So kalau kita convert yang ni, so region R, cosine of x squared plus y squared dA. So this is just from 0 to 2 pi, from 0 to 3, cosine of r squared, berhati-hati sikit, times r dr d theta. Okay, yang ni dia bukan, this is not a coefficient, this is just the function for input function for cosine. So be careful for that. Okay, ni awak boleh selesaikan. Tidak masalah. Okay, nak guna apa ni? How to use this? You can use change of variables. So this is cosine r squared, yang ni r dr. Let's try to solve this one. Okay, let's try to use, this is separate problem. Just take the integral from 0 to 3, cosine of r squared r dr. Okay, so you can see that you can use u and v. So I can say let u equals to r squared. So du equals to 2r dr. So you plug in this back. So it's from 0 to 3, cosine u, which is cosine r squared, which is u. And then RdR is just 1/2 of du. So you can take out 1/2 outside from 0 to 3, cosine of u du. So this is just 1/2 sine of u sine of u. Evaluate from 0. Sorry, I forgot to change the limit above this limit. I forgot to change this one. Okay, I forgot. Okay, let's see. What's the limit? Upper limit and the lower limit. So because we have r equals to 0, so therefore you also start from 0. And then for r equals to 3, meaning that u is 9, because u is r squared. So this goes from 0 to 9 and 0 to 9. So evaluate from 0 to 9. Okay, katakan, let's say I did not want to use u. I can also use back to r. I can say sine u is sine r squared from 0 to 3. So it will be the same thing. Okay, so awak boleh solve this. This is just a constant. So it will be sine 0 is 0. So it will be 1/2 of sine 9. So we've finished with that. So, and then plug in back. So from 0 to 2 pi, the inner integral is 1/2 sine of 9. So this is 1/2 sine of 9 d theta. So the whole thing, this is a constant. So you can take it outside from 0 to 2 pi d theta. So the value is just pi sine of 9. Am I going too fast? Saya terlalu laju ke? Okay, so saya harap awak boleh inilah ikut sebab yang ni adalah basic. Basic calculus 1. Okay, ada soalan? Any questions so far?
No.
Ada. Alright, so kalau saya rasa saya boleh stop je dekat sini. Kalau ada, sebab kalau saya nak selesaikan ke semua ni tak sempat lah kita punya ni. Okay, mungkin satu lagi saya nak buat ni. Mungkin number, let's look at for question number 16. Let's say this is number 16. Okay, so dia suruh convert, evaluate the iterated, evaluate the iterated integral by converting to polar coordinate. Okay, let's look at an example for number 16. So evaluate from 0 to 1, from 0 to square root of 1 minus x squared, e of x squared plus y squared dy dx. Okay, so kalau awak nak directly integrate this one, it is no problem. But the question is to convert first into polar coordinate. So by hook or by crook, you need to convert. So in this case, you just look at the formula. Okay, kalau saya tengok kat sini, apa yang saya perlu tukar? Which part that I need to change? So anything that include y and x. Anything that include y and x. So in this case, I have this one, which is dA. I have the formula for exponential, and I also have the upper bound for radius. Okay. Let's try to do that. Okay, so what's the dy dx to polar coordinate? This is the easiest to convert. So this is just r dr d theta. So x exponential of x squared plus y squared. So exponential doesn't change. The function doesn't change, but x and y changes. So this is just e to the r squared. And then square root of 1 minus x squared. What's that? So that's just r from 0 to square root of 1 minus x squared. So dia macam apa dia? So this is like y goes from, so kalau awak tengok dekat sini, y goes from 0 to square root of, kat sini, positive y. Sebab apa? Sebab does it make sense? So y from 0 to, yes, y from 0 to this one, and then x adalah x daripada 0 to 1. So we are looking at this quadrant. Okay, so maksudnya apa? Maksudnya x goes from 0 to apa dia? X goes from 0 to 0 to 1, right? So this is the radius. So that is just the radius. Tapi kalau awak nak ni, if you want to use, so this is just 1 minus r squared of cosine squared theta. Because why? Because x squared is just r squared. X is r cosine of theta. So x squared is just r squared cosine of squared theta. So this is the function which is equals to what? This is equals to y. Sebab apa? Sebab this one is for y from 0 to y to this function. Sama juga, this is y from 0. So this y from 0. And then y until this function. Okay, so kalau dalam case ni dia adalah, so this is just r squared sine squared theta. Sorry, this is r sine theta. Saya dah ni dah. So apa sebab saya translate daripada this one is this, and then y is this guy. Okay, so if I square both sides, saya akan dapat 1 minus r squared cosine squared theta equals to r squared sine squared theta Okay, so I bring on the right hand side. So apa dia? 1 equals to r squared cosine squared theta plus sine squared theta. So this is just r squared. So therefore r equals to 1. Okay, so kalau if you just look at the sketch, this one you can just plug in r equals to 1. Tapi kalau awak nak persistent untuk guna formula kat sini pun tak ada masalah. So this is one way, this is another way. Which one is easy for you? Okay, so if you want to convert the whole thing, so this will be integrate from theta, buat integral dulu. Okay, so this is just e to the r squared times r dr d theta, and then r goes from 0 to 1, theta goes from 0 to pi half. So it's just the quadrant 1. So why this is theta 0, and then this is your theta 2. Okay, any question? Okay, so tadi kita daripada region kita nak kepada formula. Sekarang ni kita nak tengok, kita nak compare. Sebab apa? Sebab kita nak tengok kalau kita boleh tengok region tu, kita tak perlu buat evaluation yang macam tadi kita masukkan. Kalau kita dah nampak dia punya sketch of region. Okay, let's see number 17. Mungkin saya boleh buat last problem, number 17. Number 17, minus a to a. So a can be any number. Is it good or not good? Okay, tak apalah. Okay, let's say this is number 17. Let's say this is from a to a. A can be any number. And then 0 to a squared minus x squared square root. So you can see that this is a circle. And then the formula is x squared plus y squared 3 half dy dx. Dx dy. So this is dx dy. Okay, so the first thing, choose which one easiest part. So this is dx dy is just r dr d theta. Always like that. Okay, and then let's look at the boundaries for x in terms of r. Okay, so x goes from 0 to saya rasa dia ada dia ada typo ni sebenarnya kat sini. Tak sepatutnya. Okay, saya rasa dia ada typo kat sini, number 17. Sebab kalau tengok kat sini dia adalah dx, dia tak boleh kat sini. So I think this is the typo should be right here. It should be y squared. Okay. Okay, kalau dalam case ni kita dah betulkan dia punya boundaries. Okay, x goes from this. So maksudnya x daripada x start from 0 to also, kalau kita sketch dia punya region. Okay. So x start from 0 and then until some function of square root. Sekejap, sebab saya rasa dia ada problem dengan soalan ni. Okay, sekejap, tukar balik. Let's change this one. This is not x. It should be this one. This is x squared and then dy dx. Now it makes sense. Okay, sebab dia x goes from a to a. Okay, let's look at the original region. Okay, dx dia start daripada minus a to a, and then you have like a circle macam ni, tak cantik pun. So the circle is just, so this is just x squared plus y squared equals to a squared. Okay, tetapi let's look at which part, is it above or below. So kalau dalam case ni, this is start from 0, y is positive, this region is y is positive. Okay, so dalam case ni kita nampak yang so by macam eyeballing, kita just by eyeballing, so we knew that r from 0 to a, and then theta goes from 0 to pi, just eyeballing, and then the equation will be from 0 to 2 pi, from 0 to a, x squared y squared is just r squared 3/2 times r dr d theta. So this is just from 0 to pi, from 0 to a, r to the power of 4 dr d theta. So you can solve this. This is easy to solve. Okay, any questions so far?